Welcome to our tutorial series on wireless power transfer using EMWORKS EMAG. This series is designed for those who want to learn how to use EMWORKS EMAG step by step in short, easy to follow videos. This is part 2. In this video, we'll select the appropriate study type for our wireless power transfer model. We'll then create a new magnetostatic study in EMWORKS EMAG and assign the correct materials to each component before moving to the next step. Let's get started.
Now let's talk about the simulation. In the simulation tab, the first step that you are going to do is selecting the study type. We can use all of these 6 study types for different kind of projects. In the magnetostatic, we only have the steady state of the magnetic solutions, like the DC currents or DC voltages and permanent magnets without any motion or time-dependent electrical sources. In AC magnetic, we will solve the simulations with AC sources. The waveform of inputs will be only sinusoidal waveforms. And in transient magnetic, that is the most completed solution type, we can model the motion, different power sources like sinusoidal waveforms, pulse waveforms, and even user-defined waveforms for current and voltages. And we have 3 study types with electrical fields: electrostatic, electric conduction, and AC electric. In this project, we will use all 3 magnetic studies. For the first and simplest sample, let's create a magnetostatic simulation, define the project, and just extract the field distribution inside the ferrites. When you choose the study type, you will see a property page. In this page, you have to define different parameters for the solution. The default values for iterative solver, residual error, and symmetry factor is chosen correctly. You don't need to change the default values, and you can click on OK. When you create a study here, you will see different parts of this study. The first part that you're going to assign is the materials. Let's select the material of this project. We know that these slabs are created from the ferrite. So let's assign this material to these parts. By selecting all of them and right-click on them, you will see different options: apply material or use the favorite material in this project. As we don't have ferrite here in the favorite material, we will go to the apply material to find the exact material that we are going to use. Inside the software, there is a complete material library that categorizes different materials in the groups like biological, cables, ceramic, steel with pH curve, conductors, semiconductors, magnets, and other stuff. And inside each of them, you will see these materials are categorized by different vendors. For example, for steel with pH curve, you will see different vendors type and their material by their standard names. You can easily search the material that you are looking for and find it. I will choose a typical ferrite here. By selecting the material, you can click on apply and close. The parts that their materials are defined will have their material name in front of the part. For the coils, when you select them, you can easily find the copper inside the favorite material. So I will choose copper for this 4 coils. The only remaining part is the outer region that we define to set the solution geometry. I will choose air from the favorite material. Now we defined all the materials for all parts and we can move to the excitation.
Thanks for watching. If you found this tutorial helpful, don't forget to like the video, subscribe to our channel, and click the notification bell to get the updates on upcoming tutorials. You can also leave a comment below to share your thoughts or questions about this video. If you'd like to learn more about wireless power transfer, visit our applications and blogs pages. The links are in the description box below. See you in the next part of the series, where we'll set up boundary conditions and apply excitations.